So this presentation will be about simplifying and evaluating expressions. So our overview of what we're going to do. First, we're going to simplify an expression, determine like terms, talk about distributive property, and actually evaluate an expression. And so the number one rule for today is you can only add or subtract like terms. So we have to have like terms. So we're going to talk about what like terms are today. So here's some things we probably know already. We know 3 plus 5 here. We know it equals 8. And then another problem here is 3x plus 5x is equal to 8x. So here all we did was we took the coefficient, the number in front of these, and we added them, 3 plus 5. And we knew x, they both had x's, so they were like terms, and we were able to add. So all we did was we added the 3 and the 5, and we kept the x. Alright, and the next problem here says 3x plus 5x is equal to 11. So what we did here was we only added, our answer says 8x. And so how did we get to 8x here? What we did was we just only added the 3x and we added the 5x together. And why didn't we add the 11? And the reason why is because we don't have an x here. If there was an x here, we could have added it and it could have been 29. But we can only add things that have the like terms. So we have a 3 and a 5, we have 8 plus 11. So 11 is just the number by itself. So how do we determine what are like terms? So the definition for a term is have the same variable raised to the same power. So an example of variables would be, or a term, 5x is a term, 3y squared is a term, 13, something like x third is a term. So you notice how after the number there's an x here, after this number there's a y to the second, after here there's nothing tied to it, it's just a whole number, and then here we have x to the third. So we have to figure out what are like terms. So in a problem like 3x plus 5x plus 11, like we did, we knew 3x and 5x were like terms because they only had the x tied to it. So you're only allowed to add when you have the same term. So our term here is x, our term here is x, so we can add it and be 8x. And 11 doesn't have anything else, it's just a whole number. So we add 11. So what do we do with like terms? So once we figured out that this was a like term to this, they were the same, they both had x's at the end, we are able to add or subtract them. We can combine them to simplify. Alright, so on page 328 of your book, example 2 is the very first time we see it. It says simplify, and it's 2x minus 5 plus 4x squared minus 8 plus 6x. So our first step is to figure out what terms do we have. So we see we have an x here, and we have an x here. So we have x. We have the x terms, and then let me get a different color. Green, we have whole numbers here. We have a 5 and we have an 8 here. So we have just numbers. So I'll just put, we have x's, we just have whole numbers. Alright, then what else do we have? Do you notice that we have something x to the second power? So we have, let's use yellow. So here we have an x squared attached to it. So we have an x's here, an x and an x. We have whole numbers, then we have something to the x squared. So what we're going to do is let's find out all the x's, the ones that have x tied to it. Alright, so we have 2x here, and we have 6x. So we have 2x. What is 6x? 6x is a positive, so we have 6x plus 2x plus 6x. So let's figure that part out. 2 plus 6 is 8, and we know we're talking about x. So we're done with these. Then we know we have whole numbers. So whole numbers here, we have a 5, a negative 5, so we have negative 5, and we have a negative 8. So negative 5 minus 8 is really negative 13. And then we also have an x squared. Our x squared is 4x squared. And we notice there's nothing else to combine it, we just have it like that. So our answer is 4x squared plus 8x, it's a plus because it's a positive number, minus 13. So our answer is 4x squared plus 18x plus 8x minus 13. So once we figure out all the different terms we have, we combine them. Alright, so one more thing we're going to talk about is distribution. So the definition of distribution is it allows you to remove grouping symbols to simplify expressions. So pretty much we want, when you're given something like this, 3x plus 5, when you have a number up against something in parentheses, you need to get that number 3 and multiply every single thing in parentheses. So for this example, we have to take 3 and we multiply it. So what is 3 times x? It's just 3x, because we don't know what x is. If we later find out x is equal to 2, we would have to multiply it. So we leave them close up to each other, because whenever we figure out what x is, if we ever figure out what x is, we can just plug in 2. So 3 times x is 3x, 3 times 5 is 15. So this is what distribution is. Here, all we're doing is we can add 6 plus 9 is 15. So 3 times 5 is 15. Alright, so simplifying example. So this is number 1 and number 3 on page 329. So 5 plus x squared plus 3 plus 3x. So our first step is figure out the terms. We have whole numbers, we have a 5, and we have a minus 3. Then what else do we have? We have an x squared and a 3x. So we're dealing with x squareds, and then we have 3x. So 5 minus 3 is 2. X squared is just equal to x squared and 3x. So when I rewrite this, I write it from the highest power. We see x to the squared, so the biggest one. So x squared, we have 3x plus 3x plus 2. So we go from highest power, this is to the first power, and then we just use whole numbers. So this is the way we write it. So this is our answer, x squared plus 3x plus 2. Here is a problem, but before we can start adding and subtracting like terms, what do we have to do? We have to distribute this negative 6 out. Alright, so negative 6 times x is negative 6x. Negative times negative becomes a positive. 6 times 9 is 54. And we're just going to bring down our 3x. So 3x minus 6x plus 54. So now we can ask do our first step and figure out all the terms we have. So terms, we only have x's, and we have x here and x here, and we have a whole number that's 54. So 3x minus 6x will give us negative 3x. So that's saying we have $3 and we spend 6. We're going to have negative 3 plus 54. So this is our answer.